Thing is blank. I don't know why it's cutting off. As x approaches infinity. Okay. But if you notice on this side, as x is getting smaller, your y is getting bigger. So f of x approaches infinity as x gets smaller and smaller. Okay. Now, the one thing I wanted you to recognize is that if you look at these are all positive coefficients. You don't have a -1 or -2 or -1/2 or anything in front of these over here. And if you notice, for all of these, for this one, when it's positive, it's going up and to the right, up and to the left. But when you have a negative in front of it, it's going down to the right, down to the left. And that's when you have an even coefficient. Oh, where is it? There we go. Now, if you have an odd coefficient, if you notice, both of those have kind of the same endpoint pattern. When you have a positive x, and you remember x to the 1, that's odd, it's going up and to the right, down and to the left. This is positive, exponent's odd, up and to the right, down and to the left. Your exponent's negative is going up and to the left, down to the right. This exponent's negative, up to the left, down to the right. And the reason why I wanted you to remember these is the fact that it's easier just to remember these two and kind of base your endpoints off those than to try and remember, okay, if it's even as this, if it's odd as that. If you can kind of picture these two, and I'll kind of show you in the example what I mean. It takes a lot of memory off the table where you don't have to remember all these if you just have the graph and you can kind of go back to it. All right. Any questions on that so far? Okay. All right, so it gives kind of a general idea. Oh, you want to still write in that? Okay. Excuse me. All right, so in general, let's say if you have for f of x equals a to the n, x to the n, plus a to the n minus 1, x to the n minus 1, and it keeps going down, a to the 1x plus a to the 0. Like I said, that could be 3x to the 5th minus 4x to the 4th minus 3x to the 3rd minus 8. It could be anything at all. So these are just numbers. And the x's are just x's raised to whatever power. So that's just a very, very generalized way of looking at it. Okay. So let's say here, just looking at your highest degree, or your highest exponent. And we say that highest exponent if n is odd. Okay. And we say the number in front of that n, let's say that's positive. Okay. So if you look at it, it kind of sounds like f of x equals x to the 3rd. Or even x to the 1st. Okay. So if you know this kind of has the same description as x to the 3rd, then you know that your graph is going to look like some variation as far as endpoints go. So you kind of straighten that out a little bit. Some variation of endpoints that looks like that. Okay, so you know this endpoint is going to go up and to the right, and this one's going to go down and to the left, simply because of that. Okay. You don't have to know anything else about it. In between those endpoints, it could go up and down 1,000,000 times. But we know those endpoints, this one's going to go up and to the right, down to the left, simply because that's the same as x to the third. Okay, so you know x to the third looks kind of like that, give or take. Okay. So that helps you, instead of having to remember all that, just say, okay, up and to the right, down to the left, just like x to the third. Okay. Like I said, inside of here, it can look like that. And it all depends on what the graph is. But we know those endpoints are going to look the exact same. Okay. So we know that f of x is going to approach infinity as x gets bigger. And we know f of x is going to approach negative infinity as x gets smaller. Uh-oh. All right. Any questions on that one? Like I said, we're just focusing on the endpoints for right now. Okay, kind of separate that a little bit. Okay. So what if we have, if n is odd, and your lead coefficient is negative? Let's say just positive, and that's negative. Okay. Now, if you think about it, that's similar to negative x to the third. Which is just x to the third flipped. Uh-oh. Okay, so if we draw our graph, area x and area y. Okay, so if we know x to the third kind of goes like that, then negative x to the third flips, so it goes like that. But we're just looking at the endpoints. Because remember, negative x to the third looks like that. Okay, so we know that one. This endpoint is going to go down. Like I said, in between here, it can look like anything at all. But those endpoints are always going to go down and to the right, up and to the left. Does that make sense? All right. Okay, so we know here that f of x is going to approach infinity, so it's going to keep getting bigger the further you go to the left as x approaches negative infinity. Uh-oh. And we know on this one, as you go further to the right, your f of x is going to keep going down. Okay, so these are just when you have odd exponents. Okay, now which direction the endpoint goes is strictly based on what's in front of that highest degree, whether it's positive or negative. All right, so inside of here, it can look like anything at all. All right. Now, when it's even, it's a different look. I'll bring that down a little bit till I'm, in case you're still drawing on it. Let's say we have our x and we have our y. Okay. So let's say we're still talking about that lead coefficient. Okay. So what if that lead coefficient is positive? And that, let's say that lead exponent is even. Kind of like x squared. So if, oh, sorry about that. So if n is even and your lead coefficient is positive, it's pretty similar to x squared. Okay. We know our x squared kind of looks like that, kind of like a u. Okay. So that means our endpoints are going to go up and to the right and up and to the left. Just kind of clean that up a little bit. Okay. Now, based on what everything else is in the middle, we have no idea how many twists and turns it could be in between that. But we do know for one thing is that going up and to the left and going up to the right, that's where the endpoints are going to be. Everything else in between we kind of figure out later. Okay, so we know that this endpoint, f of x, approaches infinity as x gets bigger. And we know it still gets bigger and bigger as x gets smaller. So f of x keeps getting bigger as x gets smaller. So either way it goes, those endpoints are going to go up. Uh-oh, sorry about that. Okay, so if we do one more, we have our x, we have our y. What if your exponent is still even, and that lead coefficient is negative? Okay, which sounds like negative x squared. Yeah, clean that up. So similar to f of x equals negative x squared, which we know just x squared flipped. Okay. So one thing we know about negative x squared is that it goes down and to the right and down and to the left. Okay, so this one goes down and to the right, down and to the left. Like I said, in between there, we have no clue. It can look like anything under the sun, but we know where those endpoints are going to wind up pointing. Okay. So just using that, we know that our f of x is going to keep getting smaller as you go to the right, and it's going to keep getting smaller as you go to the left. So we know that f of x approaches negative infinity as x gets bigger, and it's going to approach negative infinity as x gets smaller. All right. Does that make sense? All right. Any questions on this so far? All right, I'll leave that up. All right. Okay, so let's give a couple of examples. Okay, so let's say if we wanted to determine the end behavior of the function f of x equals, say, 0.2, x minus 2, x plus 1, and x minus 5. Okay, so in order to determine the end behavior, we have to know how many degrees this is. All right, so if you think about it this way, if you had 0.2 times x times y times z, that would be 0.2 times x to the first, y to the first, and z to the first. So that would be degree 3. This is the very same thing. You have f of x equals 0.2 x minus 2 to the first, x plus 1 to the first, and x minus 5 to the first. Okay. So you know if you add all those exponents together, it's just degree 3. Okay. So you have 1 plus 1 plus 1, so you have degree 3. Okay, any questions on that step? All right. Okay, so we know it's degree 3, so since it's degree 3, we have an odd, well, let's say n is odd. Okay, because remember, if we did all the FOIL and distributing and everything else, we'd end up with an x to the third as our highest exponent. Okay, but this kind of keeps us from having to do all of that. Just trust me, that's 10 minutes you won't want to spend. So this way, we already know it's degree 3 without having to do all the FOIL method and distributing and everything else. Okay. Now here, I'll just rewrite it because I don't want to mix everything up. 0.2 x minus 2, x plus 1, x minus 5. No matter what, if you distribute all that and factor to where you have this long polynomial, once you distribute that, you're going to have 0.2 times x to the third plus blah, 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 blah. So we know your 0.2, that's your lead coefficient. Which, in our general formula, is our a sub n. Because remember, we're just going by the f of x equals an plus xn plus an minus 1, x to the n minus 1, etc., etc. So this is our lead coefficient, where we know that it's positive. Okay, so we know that if, move that up a little bit. So if n is odd, excuse me, and a sub n, remember that's positive, is greater than 0, what does that sound like? That's pretty similar to x to the third. Okay. So if you can remember how x to the third looks, because remember, you have an odd exponent, and the number in front of it is positive. So if you remember x to the third kind of looks like that,